Kinematics, the science of motion. Most of us hear this word and feel sick, but have you noticed? You are surrounded by it all the time, and whether you are aware or not, you encounter kinematics every day. For an instance, an urban rail transit or any transportation that you used utilize the wheel, preventing gravity from halting the movement of an object, allowing it to act as a constant flowing object. And even when you decide to run your dog in a street, you use force over your mass to increase your rate of speed. Even the traffic police use kinematics to decide whether you obey or disobey the law. And that leads us to our topic, the science of motion. These particular examples of conditions like time, position, velocity, and acceleration. You need the formula that links all of them together. These are called kinematic equations. Kinematics is the branch of mechanics concerned with the motion of objects. The beginning of the word kinemat is Greek and means motion. The end of the word ix is Latin and means the study of. Putting it together, kinematics is the study of motion. Let's say you're driving a straight pathway. You come across a red light, so you stop. Then the light turns green and you hit the gas. Exactly 7 seconds later, a police made you stop. You were given a ticket for speeding over 100 km/h zone. But were you really going that fast? You need to figure out another way to know how fast you were. Here is where kinematics comes in. Let's talk about first the 4 conditions of a motorcycle. Time tells how long you were driving for. Position lets you know where you were and where you are. Velocity tells the way of your position changes over time. It is like a speed, but it has a direction. And acceleration lets you know that your velocity is changing. The use of graph is very useful to show the change in your position. The x represents the distance and the t is the time in seconds. These examples will help you better understand. Let's say you're just still in your position for 4 seconds. So your distance will be in the flat x4 line, and the graph will look like this. Let's say you're speeding up 1 meter per second from rest and you stop at 4 meters. The line would be diagonal to show the change in your position for 4 seconds. And from the 4 meter line, you start to speed up, then after 1 second, you went 3 meters, and after 3 seconds, you went 6 meters. The graph will look like a curvy line. For the graph of velocity and acceleration, it is quite similar. You just have to change the component in the vertical axis. The equation we use to find the average velocity is the change in position over the change in time. Based on the third example, if we are going to find the change in time, we just subtract its final value and its starting value. So 13 meters minus 4 meters, 9 meters is your position, divided by 0 second minus 3 seconds or 3 seconds. 3 meters per second is your average velocity. In average acceleration, the equation is the change in velocity over the change in time. We have the definition of acceleration as one of the main equations of kinematics. Instantaneous velocity equals the velocity at time 0 plus the product of acceleration times time. Second kinematic equation is the displacement curve. It is position minus initial position equal to initial velocity times time plus 1 of acceleration times time squared. So the two main kinematic equations are the definition of acceleration and the displacement curve. So these two other kinematic equations is just a rearrangement from the two main equations. So now you already harnessed the basic power of kinematics. We are now going to find out if that police who pulled you over is really doing his job. The initial velocity towards north is 0, and your time t is 7 seconds. But we need to find first your acceleration. Here is the formula fit for finding the acceleration. Then we substitute all the information given by you. After solving, we find out that your acceleration is equal to 5 meters per second squared. Then we will now find your velocity using the definition of acceleration. Substituting all we have in the equation, we get v is equal to 35 meters per second when the police pulled you over. 35 meters per second when converted to kilometer per hour is 126 km per hour. After doing the math, you really overspeed the limit. You deserve the ticket. Sorry.